Right. So now that we've talked about what are the costs and benefits of climate change actions, let's look at how we're going to weigh those two up in a cost-benefit analysis. So there's several steps. It's essentially quite simple. What you first do is you estimate a business as usual scenario. What's going to happen if we don't undertake any action? If we do nothing, what are going to be the future costs and benefits? Right? Then we estimate the cost of taking adaptation or mitigation actions. And these include the direct implementation cost, but also maintenance cost and the opportunity cost. Then we estimate the benefits. And I just talked about those before. Market and non-market benefits and how they change over time. The fourth step is a bit more difficult, and I'll explain it in more detail. What you do when you have all that cost and benefit information is you compare the whole stream of cost and the whole stream of benefits over time. And because in general future cost and benefits carry less weight than immediate cost and benefits, we're going to discount future impacts, resulting in a net present value of the policy change. We're going to compare over time whether we're better off or worse off with action compared to the business as usual. So to summarize a benefit cost analysis, we estimate over time all the social costs and benefits that arise from taking actions to avoid climate change or to protect ourselves from climate change. All these costs and benefits are estimated in dollar terms because that gives us one unit of measurement to compare. And we discount future impacts and then compare the discounted net benefit with action against the discounted net benefits of the status quo of the business as usual scenario. Now, this is the same idea, benefit cost analysis in equation form. We look at the net present value. So the net value means the benefits minus the cost, benefits minus cost, net benefits. We look at the benefits of taking action, the cost of taking action, and we're looking at whether those net benefits are greater or smaller than the business as usual scenario. Now, what's all that scribbly bit here below? That's the discount rate. We discount future benefit and cost, and we look at the discounted benefits over time from time 0 to the end of time. That might be 2 years, might be 3 years, might be 10 years. The same for the cost. We discount the cost, add them all up over time, and same for the business as usual scenario. I'll work you through a few examples. We're looking at the net present value, which means the total discounted cost and benefits over time. Why do we include that discount factor? Why do we discount the future? It's because people usually have preferences in time. Typically, when you have a benefit or a cost occurring today, you put more weight on it than if it happens next week or next year. For most people, getting $1 today is worth more than getting $1 next week. Say, if I ask you, would you rather have $100 today Or would you prefer me to give it to you next week? Pretty much all of you would say, I'd rather have it today, thank you. It's because we value impacts now more than impacts in the future. And the discount factor takes account of this. It accounts for the fact that we attach less value to future impacts. But there's a whole discussion going on what discount rate to use. Because if you, for example, use a high discount rate, it means that you put less value on the future. Whereas if you use a low discount rate, it means that you have a more equitable view. That you care more about future benefits. So let's see if you understood. If you think that we should preserve ecosystems for future generations, do you then generally have a low discount rate or a high discount rate? Whereas if you think we should maximize economic growth now, do you then have a low discount rate or a high discount rate? Right. Preserving ecosystems for the future means that you have a low discount rate. You think the future is equally important than today. Whereas if you focus on maximizing economic growth now, you have a high discount rate. You care more about the now than about the future. Let me show you an example in equations. And we're going to practice with this, both now and in the tutorial. This is the generic function for discounting. We have the present value, which is equal to the future value divided by a discount rate. I'm in the wrong screen. We have a present value, which is a future value divided by the discount rate. I have two examples here. Present value of having $1,050 next year is equal to having $1,000 this year, if I use a 5% discount rate. My other example is having $550 next year plus $550 the year after would be equal to having $1,013 this year, now. So it's discounted for year 1, discounted for year 2 at a 5% discount rate. So let's look at another example. This is an example where I've used a 10% discount rate. This is a project that goes over 5 years. The first year we don't incur any benefits, but then benefits go up over time. But the present value of those benefits are discounted by 10%. So I've calculated that for you. Whereas the costs are quite high in year 0 because of high implementation cost. And then there's some maintenance costs that we incur and they go down over time. And those costs are also discounted. So we have the present value of the benefits, the present value of the costs. We add those all up, just like the equation that I showed you, which yields me present value of benefits of 1,014, present value of cost of 1,136, which means that we have a net present value that is negative, which means that the present value of the cost is larger than the present value of the benefits. And this project should not go ahead. This policy action should not be implemented. That's using a table. You can also put it all in the formula. We have net present value is the same as the initial investment, because there wasn't any benefit, plus benefits, discounted net benefits year 1, etc., until the last year. And I've put that in for you here. The initial cost, the net benefits in year 1, the net benefits in year 2, the net benefits in year 3 and the net benefits in year 4, all discounted with 10% discount rate. So the initial cost and the net benefits for the next 4 years. What I want you to do in your next break is solve that equation. You can do it in Excel, you can do it with your calculator. And we'll come back after the break to look at the solution.